So what am I going to talk about? I'm just hopefully I just want to talk about kind of maths in early years and how do we make sure that maths is everywhere, every day, what can we do, those kind of things. So I'm sure I'm not going to tell you anything new, but hopefully I will share with you some thoughts and things as we go along. So I thought, although Kelsey has introduced me, I thought I'd just give you a little bit of background. So I always class myself as a teacher. That's me, in that kind of that far left corner, kind of at the board. And I've taught in a variety of schools, unfortunately just in England, although my brother-in-law is from Wales, so I have a slight Welsh connection. And so I think kind of being in the classroom, kind of being there has, really afforded me kind of that understanding of, really how children learn. And although I am now a mathematics advisor, I still teach as much as I possibly can. So I'm still a governor. I've been a governor at the same school, an infant school, for 25 years, and actually 26 years. And if I kind of feel that I haven't been in the classroom for a little while, I just, call up the math subject leader and say, can I just come in for the day? And I'm just gonna do a bit of teaching just to keep my kind of, feet on the ground. Um, so kind of my journey with maths is interesting. When I was at university, I thought I was going to specialise in English and PE. And in fact, that's what I did. And I tried to avoid maths as much as possible. So it's kind of always a bit of a revelation to remind myself that I am now in the world of mathematics. But I think what that means for me is that I really understand why a lot of children struggle, why a lot of adults are a little bit kind of resistant to maths, because I was definitely one of them. So no question is by any means a silly question. I would have already probably thought about it. Pile of books is, as Kelsey said, I just love research. I'm passionate about research. I'm going up to Glasgow at the end of August because Glasgow University have just opened a brand new spatial reasoning cognition centre, and they're having their very first conference, and I'm going to do a presentation up there. Um, you might be kind of thinking that kind of the globe, the map, as Kelsey alluded to. I am now a freelance advisor. I did work with Norfolk Local Education Authority for 18 years as their advisor, and I looked after around about 420 schools with some colleagues. But then I went to freelance, and I think I have the best job in the world. I literally get to live and work in England, but travel the world. So I think to date I've worked in 35 countries. So I was in Vietnam last week, and sometimes it's training teachers, sometimes it's doing audits. I'm working with the Maldivian government at the moment because somebody has to. It's me. That's okay. And kind of working on kind of all of the subjects there. The pile of Lego bricks is just to remind me to tell you that I am a Lego education trainer. So I train anybody that wants to become a Lego education trainer. I'm one of the people that trains you and certifies you. And Peppa Pig, has Peppa Pig made it to Wales? I never know. But if you know Peppa Pig, then I guess I can tell you that I am Peppa Pig's maths advisor. I mean, who knew there was such a thing? But yes, there you go. So that's kind of me in a nutshell. Okay, so kind of what kind of things are we going to explore this morning? So we're going to think about, how can we support our youngest learners to be? I love that phrase, to how can we support them to be a mini mathematician? And therefore, what does maths look like in an early years setting? Because as the early years curriculum is designed to be holistic and play-based and child-led. So, if children are spending, many hours in the sandpit or in the book corner, are they accessing mathematics? And I'm going to just talk through the things that we can do to enable mathematics to be everywhere. And of course, that big question, can we do maths outside? Absolutely. Should we do maths outside? Yes. So it's kind of one of my lovely colleagues, Sue Gifford, has this mantra that I like to borrow. And she says, do it outside, do it large, do it big, everything that's happening inside, do it outside as well. So that kind of question about can we really see maths everywhere? I'm hoping by the end of this webinar, you will kind of, join me and say, yes, we can. So what I thought I'd do now is I'd just kind of just dive into the research just for a tiny, tiny little bit, um, and really kind of just think about, well, what is it that we know? And we know that maths matters. And I know that kind of seems a bit of a kind of a strange thing to say. We're all like, well, of course maths matters. But actually what we do know, and this is based on research, which I'll share with you, is that children who start behind, when they start kind of, reception, so, going into their kind of their fifth birthday, if they are behind at that point, they often stay behind for their whole of their primary year experience. And that's quite kind of hard message, isn't it, to think about. Now we can close that gap. So it's not kind of, everything isn't lost by the time they get to reception, but the further through primary school they go, the harder the gap gets to close. So as much as we can do before they start formal schooling, the better, because we then can keep that kind of, that progression going. We also now know, and this is kind of often a bit of a shock for people, that maths is the biggest predictor in how well children do overall. So not English, not phonics, not reading, maths. And that's quite amazing, isn't it? And that comes from the Early Intervention Foundation research. And we've also now got the same piece of research from the EEF as well, the Education Endowment Fund. So, when I'm looking at children in an early years setting, I'm really looking to see what maths they are accessing, because I know that that's going to impact them when they're 11 years old. And of course we know that when they go to secondary school the gap widens, so we want to try and give them as much of a fighting chance as possible in that primary school. And therefore, that's why I talk to lots of head teachers and say you need to put all of your energy, all of your funding pretty much into early years. We get it right in early years, and then, those children have got a really good chance. So what are those predictors? So these, again, I've kind of just given you the reference. So this is what, I mean, this is not new research, but we know that early math skills, and I'll talk to you about what those early math skills are, have that greatest predictive power of later achievement. So again, something that I'm battling a little bit in England because we're so obsessed with phonics. And I get it. I understand that phonics and being able to read is important, but it's not a predictor of how well children will be kind of as they go through school. We know that preschool number knowledge helps. I'm not telling you anything that you don't know, but that is actually coming from the TIMS research. And we also know that, and this is the EPSI research, that for preschools, those preschools that helped children to understand number concepts in particular led to better outcomes at 11. So we've got all of these different strands of research saying actually maths is really, really, really important. So what are the predictors? Well, there are kind of three. And this is kind of when I'm talking to schools about their early years curriculum, because we don't have an early years curriculum in England. We have a statutory paragraph, but we don't have a curriculum. So when we're looking at designing and writing and creating a curriculum, these are the three areas that we look at. So the first, you won't be surprised, is number sense. And again, lots of research there that I've just given you an indication if you want to follow it. But we'll talk about, and what I'm going to do for the rest of the webinar is kind of unpack these a little bit as well. So number sense is your first one. Patterning is really important. And I think before I started with the pattern research, I kind of thought, someone would say to me, do you do pattern? I'd be like, yeah, no, I do pattern. Then I read the research, and then I did a research project with schools in Norfolk and Suffolk for 4 years. And then I was like, oh no, actually I didn't do pattern. I thought I was doing pattern, but actually I was doing it in quite a low level way. So pattern awareness, super, super important. And alongside that, spatial reasoning. And this might be a new phrase for you. Actually, we're quite good at early years. It's actually probably a phrase that we use more in early years than in any other phase of kind of the, the school age. But actually, it's one that's really important. And again, I'll unpack it, but basically, it's at a very kind of low level sense, it's kind of your geometry, it's your shape and space, but it's so much more than that. So I will unpack those three. But of course, I just want, just to acknowledge really that, language development is so important. So I don't want you to think that I'm saying we don't do language, we've got to just do maths. Of course, we've got to do language. And there's one of the statistics, that by the age of 3, lots of children, particularly disadvantaged children, are almost a year and a half behind their peers. So, of course, wrapped up in mathematics is all about that language and that oracy. And there's just another kind of quote. You've probably seen these before, but it's good just to be reminded, isn't it, that again, it's that kind of that critical age of 5 and 6 years old, kind of, by the time they get to kind of going into reception, starting formal schooling, if they are behind, 11 times less likely to achieve that expected level in math. So that's kind of, where we're looking at as well. And that's from that piece of research. Again, not new, but just there. Okay, so how are we going to do maths every day? And how are we going to do it all day, every day? That's the big question, isn't it? That's what I'm here to talk about. So I'm going to just break it down into kind of the pedagogy. So first of all, we would have direct teach sessions. You might call it something else. It doesn't really matter, but I always describe it as this is the bit where I'm in charge. So I like to think. This is the bit where I'm possibly sitting on my chair and I've got the children around me and I have an idea of what we're going to do. And so I'm kind of leading it. It's teacher led. It's probably the thing that's on my planning. So that's what I would call my direct teach. Then, of course, we have got the guided play as well as the child-led play. And again, those two things are quite different. I'll just take back routines. So that guided play is, where I might be observing children and I might think, well, I'm just going to go alongside them and play. I'm not going to kind of say, what are you doing? Because then I've interrupted them or, tell me what you're doing. I might just be kind of, playing alongside. Equally, if I've looked over at, for example, a construction table and I think, nobody's there, and it's quite hard, isn't it, to say, oh, Hannah, come and play with me. Hannah's like, I don't want to. I always use Hannah because that's my daughter's name, so hopefully no offence. So sometimes I might just go to that construction table. I might just start playing, and hopefully the hope is that the children gravitate towards you. And then, of course, there's that child-led play, which is, again, both in continuous provision. Routines, I'm going to talk a little bit about routines because that's a really good way of how we can get maths kind of in a way. And of course, the environment. The environment is your best friend. If we get the environment right, it's like having, invisible teachers all around helping you. So let's talk through those kind of things there. But usually what I see, particularly when I work with my early years practitioners, is that when I look at their planning, the only thing they've included for planning is that direct teach session. And what I've started to do is to say, well, hang on a minute, if we included all of those other things that you do, which I'm going to show you, actually you'll find that you're doing maths quite a lot each day. It's just that 10 minutes direct teach session is all that you're thinking about. So I remember when my governor's school was inspected a couple of years ago, we'd worked really hard on the early years, and the inspector kind of came up to the early years lead and he said, oh, I want to come and see maths. When do you do maths? And she said, we do it at 9 o'clock, 20 past 9. We then probably do it at 10 past 10. We do it just before we go out for lunch, just before we come back. And he just said, oh, I'll just come in for the day. So it was the idea that actually, did you want to see number, or did you want to see spatial reasoning or patterning, and where do we do it? So there we go. So let's start thinking about routines. So the rough definition of a routine is that it's something I've put something that happens every day. Maybe every day should be in inverted commas, most days. And you will have lots of routines that you do with your children. So I've just picked four that perhaps all of us might be doing. And I'm just going to show you how we can mathematize a routine, because you don't have to. And it might be that some days you've mathematized registration and other days you've given it a different subject stance. That's absolutely fine. But obviously I'm obsessed with maths, so I'm only going to talk about maths. So those are the four. So let's have a look at what we could be doing. So registration, obviously this is kind of twofold, isn't it? We've kind of got that legal responsibility to actually register how many children are there, and if they're staying kind of for the day, you know, who's having lunch, what type of lunch, etc. But actually, we could take a little bit longer, mathematise the registration, and start to involve children. So, for example, you can see that we are using our 10 frames. Now, I can't even see where I am. So, I hope I'm holding those 10 frames up. So, these are just kind of some of the 10 frames that I tend to use. I use 10 frames a lot. I also use 5 frames as well. So, these are the Hungarian 5 frames. And if I put two Hungarian 5 frames together, I get a Hungarian 10 frame. And actually, I would start with Hungarian 5 frames, even for registration. Maybe I would do that in the autumn term, and then maybe I would move on to what I call the linear 10 frame in the spring or summer. But I can do this in lots of different ways. So you've got two examples on the screen. It might be that as the children come in, first of all, they have a little picture of themselves, and as they come in, they register by putting their photo in one of the cells. And to begin with, they put them everywhere. You know, there's one here and there's one here. But over time, we teach them, we model that actually filling one frame to begin with is really helpful. And of course, once a frame is filled, then that represents 10. So we can start to build up that composition of 10. And of course, if I put another frame underneath it or next to it, I've then got a 20 frame. And we can just be using these words, just very matter of fact. And you will know that children are just sponges, aren't they? And they just pick up everything. So I might start with faces, and then you can just see that it's quite a blurry picture, but you can see that then the frame in the bottom right hand corner it's actually got numbers on it. So it's got the numerals. So just bringing in that numerosity, and children are just putting a stone. And then we're starting to teach them that, you know, if you're the first person in, put the stone on number 1, second person, number 2. So actually we're doing counting, but we're also doing composition of 10, but we're also doing ordinality. So we're doing quite a lot just by mathematizing registration. I'm going to just keep on going to explain the other routines, and then I'll just stop and we'll just kind of, you know, see what people are thinking, maybe give you a chance to talk. So lining up, I mean, we do quite a lot of lining up, don't we? So we might line up to come into the classroom, we might line up to go out to play, we might line up to go out to lunch or to go home. And this is an opportunity. So if you imagine how many times you line up, you could take one of those lining up opportunities and mathematize it. So again, you don't have to do all of them, but it could be that you want to say to people, to children, right, okay, well let's line up in a pattern. So again, got to be careful, haven't we, how we kind of use children's attributes as a patterning. But it could be those children that have got a jumper on and those haven't. So we want to go jumper, no jumper, jumper, no jumper, or socks, no socks, or those kind of things. So we're just starting to build up a pattern. We could be, oh, great, everybody's lined up. Who's first? Who was first? Who was second? Who was third? So getting in that ordinality, just counting, just getting the children lining up, and then just saying, right, let's check we've got everybody. How many people did we have here today? Did we have 24? Let's check. 1, 2, 3, 4. So we're doing that counting, again, that one-to-one correspondence, that stable order. And we could even be doing sorting. We'd be like, okay, actually, can we sort into those children that are having lunch, or those children that are not, or whatever it is, or can we sort into 2 lines? So again, I'm not using the word let's do multiples of 2 or let's do doubling and halving, but I'm just getting those kind of those concepts, just kind of developing that kind of early number things going on. Tidy up time. I love tidy up time. And actually, I'm just going to talk you through some of the things that you can see on these photos. And these are all photos that, various of my teachers have done. So again, tidy up time is a really good opportunity for mathematizing and getting some maths in. So let's start with looking at the photo of the shelving on the left-hand side. So what you've got here is shadowing. So, and there's quite a lot of things going on. So on that top shelf, you can just about see that those pots are being placed on top of a shadow. So now I know that spatial reasoning is happening. That spatial awareness. Can I actually place that pot on top of its shadow? And you'd be amazed how some children can and some children can't. So I already know that we're doing some matching and some spatial reasoning. But can you also see that those pots have been designed to do some sorting? So all of the orange pencils go into a pot, all of the blue pencils and red pencils and so on. So this teacher has decided that's how she is going to sort. On the bottom shelf, again, the scissors, if I want to almost move one of those scissors, but they've been shadowed. So again, but can you see the A-B pattern that's being happening? So scissors, upside down, right way, upside down, right way. So we've actually got an A-B pattern of scissors also on top of shadowing. So there's actually quite a lot going on there. Same for the pencil sharpeners, and I think they might be rubbers, I'm not entirely sure, but I love the Pritt sticks. Have you noticed the Pritt sticks are in the spatial pattern of 5? So again, just a little thing going on there, but getting the children used to subitizing that 5, seeing that 5 in a spatial array, not array, a pattern, is just kind of building up all of the things. So already there, I've got counting, I've got some spatial reasoning, I've got some patterning. The picture in the middle, you can see that actually we've got a number track, and actually it's a correct number track because the 0 is outside the number track. I was looking at a resource yesterday and they'd included 0 in a number track. I'm like, how do you jump on 0? You can't have 0 in a number track. Oh, Emma, I'll come back to you in a second. Yes. So it's really good to see that 0 is outside. But again, the children have been asked just to bring back the pencils, and now they're lining them up. So we've actually got a little bit of measurement, a little bit of length going on there as well. And the children are learning that they don't just put the pencil in where the number 8 is if the first 7 pencils haven't been followed. Just going up to those last 2 pictures, again, you've got the scissors, and this time the pot has said, actually, we want 5 scissors in here, not 4, not 6, we want 5. You've got the numeral, but you've also got the dot counting as well, so that children can be counting, okay, I've got 1, 2, 3, 4, 5 scissors in there, and the same with the pens. And then underneath, the sand timers, where do the sand timers go? They go on the shelf, but just by putting that number 1, 2, 3, 4, 5, first of all, the teacher can see if the sand timers are missing, always helpful, but also the children are starting to get that ordinality as well. So that was tidy up time. And then that last routine that I was just going to talk to you about is snack time. So again, it depends on, you might have a rolling snack, or it might be that you do bring children to the snack table kind of throughout the day. So if you do, this is a lovely way of getting a little bit of data handling in. So you can see the teacher. In fact, this is actually a book. So actually the snack time, that it's like a record of who was there. So kind of over the course of a week, you don't have to do this with, all children every day. But the children have been recorded. I think this must be Libby who's in charge of snack today. I can see Libby's name. And strawberries, bananas, cucumbers, biscuits. Gosh, this must be a good school. They've got all that snack. But you get the idea that actually number of children, so they're just starting to do a little bit of tallying, and then the following day, orange, apple, biscuit, doing some really nice tallying there. So just mathematizing that snack. Doesn't have to be a lot, just a little kind of, a kind of nod to the maths. And that's really what we are wanting to do. So let's think about the impact of the environment. So what can we do with our environment? So I've already talked about, continuous provision. And again, I kind of understand that you might have different kind of words. So for me, continuous provision, it's kind of the areas that I have out available all the time. So I'm going to have a book corner. I'm going to have probably a maths area, but I'm going to come back to that in a second. I'm going to have sand and water, or maybe I have to alternate sand and water depending on kind of space. Definitely probably want role play, construction, art and craft, mark making. So I'll have those kind of things all the time. But what I'm going to do with that continuous provision is try to change where it is, because if the book corner is always in the same place, then actually children just get a bit bored of going there. There is that kind of, it's nice that they have it maybe in that place for a term, so they know where to go, they feel comfortable, but then keep changing it, because kind of changing up the order and changing where you put things, it just creates a little bit of interest. But also it helps children's spatial awareness. So they're kind of like having to navigate around the classroom in a different way. For me, enhanced provision is putting something out that links to my direct teaching. So if I've been doing some patterning work, then I'm going to have a table that picks up that patterning work that the children could go to if they want to then carry that on. So it's enhancing the kind of the direct teaching for me. I'm going to think about my inside provision and my outside provision. So I often just walk around the setting and I'm just thinking, right, if I want to go to that particular area, what maths could I do? So that's kind of what I'm thinking about. So I kind of talk about this maths friendly spaces. Now that's not the same as the maths area. And I kind of have a bit of a working theory that children don't really go to a maths corner or a maths table. I think the maths area, or whatever we want to call it, is kind of where we put the maths equipment, but it isn't necessarily where children go to do maths. They tend to go everywhere, and they often tend to transport, various bits of maths equipment to help them. So we then need to look at and think about all our spaces and think, are they kind of maths friendly spaces? So these are some of the questions that I ask as I'm kind of going around the setting. So do children want to spend time in that part of the setting? Do they go there? Do they not go there? And I always remember I got really excited one year. I'd been out, so I can't remember where I'd been, probably the middle aisle of Lidl or Aldi or whatever, and I'd seen that they'd got this rug and it had paw prints on it, and I was like, wow, that is amazing. It was quite a big rug. I thought that's brilliant. What I'm going to do is I'm going to set up kind of like a kind of a dog area, dog kind of thing, and we'll get cuddly toys out. We'll have leads, and we'll have, the children can be role playing. Not one child went into it, not one, because I'd set it up. And so they didn't want to spend time in that part of the setting. So after about 2 days, I was a little bit deflated. I just took it all down, left it in the middle, kind of in a bit of a pile. And over the next couple of days, children redid, they took it, and they kind of then did set up this role play kind of dog area. And I'd kind of done that because the children, had been excited. I think one of them had got like a puppy or something, following children's interests. But because I had taken charge, the children didn't have any agency. They didn't have any interest or accountability in it. As soon as they did it, brilliant. So that was a good lesson to me. So comfortable seating, I'm very much of the opinion that you don't have to have lots of tables and chairs, but comfortable seating could be bean bags, could be rugs, that kind of thing. That kind of open floor space is really important. What about the lighting? And often, that lighting could be fairy lights in a tent, in the middle of the classroom, but different levels. And I think that's really, it's it's quite hard to create inside, but I think it's really important. So, trying to get some crates that children can climb on top of and put a rug over and a beanbag, and that could be their beanbag corner, that could be their book corner. But, we want children to be accessing different levels if they can, because that's also supporting their spatial reasoning. So I've just took a few. These are some of the photos from some of my schools. I just asked if I could use them, and they were like, "Oh, very excited, yes." So this, I guess, is kind of the maths area as such. But you can see that there are big numbers, so it's quite attractive. The children can kind of see what's happening. The kind of the trays that you're looking at, that's actually the counting corner. We've been doing a lot with my early years consortium. We've all got counting corners now. We're looking at the counting collections research from Nottingham University. Just Google it, it's amazing. So we're doing a lot of counting, and that's really kind of bringing up the levels of number for our children. So there is a table in the middle there, but you can see that kind of the unit closest to us, what the teacher did is she's turned it at an angle to kind of create that zone. And that's now really created a nice space. It also means that children have to navigate round it, which they find hard. And I think you can just see on the floor, she's taped that red tape. She's taped a giant 10 frame on the floor. So lots of things going on there. But does it look attractive? Do I want to go there? Actually, I'm quite excited. It's quite colourful. It looks quite interesting. I like the kind of the furniture at an angle. That's kind of, it's kind of drawing me inside. So I think it's about, thinking about, can we get maths everywhere? They don't just come together by accident. We definitely have to plan them, but are they offering that rich, meaningful, playful experiences for children? So that's kind of inside just from that point of view. Outside, again, what kind of things might we see for maths outside? So very much about kind of, if you've got you might have your trikes and your bikes, but equally, this is quite, the small kind of play equipment. So there's just some numerals that have been on the floor, painted on the floor in order. You can also do them in chalk, although that kind of obviously washes away. And the children are just sorting them. So but just by putting that phrase checkpoint, it's giving the children a purpose for why they're now going to be putting the cars there or the vehicles. So you can see that they've got a 0, but there's no dot for 0 because you can't have a quantity of 0. So the dots start at 1, 2, 3, 4, 5, and so on. And the children are placing their vehicles on there so they can then see how much, what cardinality, what number they've got in total, but also kind of that ordinality there as well. So I'm going to carry on, keep talking about, maybe some of the maths areas that you might have. And again, I could have probably done another list as well, but I stopped. So things like I've already mentioned, accounting library or accounting corner, super, super, super important. We know that counting is the gateway to calculating. So counting, doing lots of counting, but also using counting as an intervention strategy as well. So a lot of my teachers are now having a counting session 2 or 3 times a week in addition to their direct teach session. Whether they're doing counting in their direct teach or not, the counting, kind of the counting library and that using their counting collections is really important. And I'm really happy to talk about that more if you want me to. We've then got the sand pit and the water area. I'm going to talk about that a little bit more in a second. Pattern station, again, that pattern is really important. It's kind of what I would say a third of number, third of pattern, third of spatial reasoning. So we've got the pattern station there. So that's something that as much as possible, if we can have there and keep, that would be good. Weighing station, again, children just love to weigh, and we've got that comparison going on. Estimation station, again, that's a really lovely enrich activity where the estimation station children can go and basically estimate and write numerals and that kind of thing. Book corner, I'll come back to. Voting station, again, a really, really nice, very simple way to get a little bit of maths in every day. Here are two books that we're going to read one of these books at the end of the day. Let's vote which one. And we can vote by kind of having some Duplo, or we can vote by putting a conker in a pot. And then we're just going to count them. So again, that counting's coming out. Oh, look, which one? This book has 5 conkers and this book has 7 conkers. So which book has got more votes? Which one are we going to read? So you've got your counting, you've got your cardinality, and you've got some statistics in there as well. And it's just part of continuous provision. Detective Den, again, I'm sure I don't need to explain that. Mud kitchen, again, that following those recipes. So you've got your measurement there. Construction corner, I'll come back to. Even just having a measuring bench or a potion station. So lots and lots of things. I tend to write a long list and then think, right, what am I going to have in September, October, November, December, and so on. So just keep on going and going. Okay, I'm going to just breathe. Everybody okay? Okay. So I just want to talk about manipulatives, and then I'll talk about maybe some of the maths manipulatives that you might want to think about having as well. So manipulatives, these are the things that children can hold, different to a representation, something that you can see. So a manipulative, why do we want manipulatives? Because we really want manipulatives in every setting and every classroom. So first of all, the reason we use manipulatives is they help children to make sense of the maths. They help teachers to see what children understand. Because all of the children have got some manipulatives, they've got them in their hands, hopefully that enjoyment and that engagement increases. They definitely help to develop that visualization so that, put it in my head, imagine, manipulate that information, huge part of spatial reasoning. They do help children to work together as well, and they are there to help children solve problems and kind of do that problem solving and that reasoning. And they do provide that bridge, because maths is so abstract. What does number 5 look like? To a 2 or 3-year-old, it's just a word that we use. It doesn't have that meaning in a quantitative way. So let's have a look at manipulatives. I'll just put them all up and let's see what we think. And actually at this point, where is the, I'm going to just stop sharing for a second because I thought I would just show you them as well. So what did we have? And I don't know kind of, what you're thinking about manipulatives, but so Numicon, is this something that you have? You kind of got access to Numicon? Maybe? Don't know. It's really, it's a very, very powerful manipulative. So it comes in lots of different ways. This is just the one that comes in the box. I'm trying to hold it so it doesn't all empty onto my computer and make a big noise. So we can have Numicon everywhere, and you'll see when we get back onto the sandpit, one of the things that you can have in the sandpit is you can have the Numicon tiles just buried for children to find. And that in itself is enough for the maths, or they can be putting them in the water tray and fishing them out. Because what the Numicon is doing is that it's offering children cardinality. So, we can see what we want them to do is to be able to pick that tile up and over time say that's a 4. Now, we do a lot of work for them to get to that bit. But, knowing that that's a 4, that's the subitizing, that's the cardinality. And then knowing that 5 is 1 more than 4 is really powerful. I can't quite see. I'm trying to do, sorry, that's 6, isn't it? That's not, there's 4. No, there's 4. Nobody kind of told me. I was like using the wrong tile. So there's my 4. So knowing that 5 is 1 more, bring in the 6 like I meant to, and being able to put the 4 on top and see that 5 is 4 and 1 more. So Numicon, I don't travel without my Numicon. And if any of my friends, have a baby, guess what they get as a present? Okay, so there's the Numicon. The Cuisenaire, again, don't tend to see this a lot, But again, it's really, really important. So your Cuisenaire, these are your Cuisenaire rods. And I would, again, I just have these out. The children can be playing with them. There are 10 rods and they're all proportional. So children can just make things, they can make pictures with them. But over time, they actually, I'm going to tip them out, sorry, bit noisy. But over time, they get to realise that the yellow is half of the orange. And they don't necessarily have to use that language, but they just start to kind of, build up their knowledge of proportionality in terms of those numbers. So Cuisenaire, again, oops, sorry, bit noisy, I would have there as well. Washing lines, again, I'm a massive fan of washing lines, and I love it when, the children come in and they're like, I'm like, oh no, the washing line fairy dragon, whatever, use whatever fictional character you want. They came in and they messed up all the numbers. Can anybody help me sort the numbers? So again, that's not a big direct teach. It's just something that the children come in and they're like, oh, it's the washing line fairy bean again. I'm like, yes, we'll sort it out for you. Okay, thank you. Things like having the multi-link or the unifix, the cubes, the interlocking cubes are really, really nice, as well as having the non-interlocking cubes for your pattern work. Bead strings, again, I tend to use a bead string with 100 beads on, even for very young children. And then if I just want to section off 10 beads and just use 10 beads, I can. But I like using kind of that 100 grouped in tens. I think it just gives the children kind of, exposure, and they like to use it for measuring as well. Place value cards. These are, again, I didn't tend to use these, but then I was reading some research by kind of Sue Gifford and Co. They're making numbers book, and I saw that they'd been using them, and I thought that's just a really nice idea. So I'm just going to hold up some place value cards here. And again, I'm not necessarily going to do a huge amount with these intentionally. I'm just going to have them out in the environment. And of course, when we just start to play around with that's a 10, oh, actually, that number is 12, but actually it's a 10 and a 2. It's just a really nice kind of way of just kind of making sure that that composition is holding. Again, I often use the word exposure. We're doing a lot of exposure in the early years. What else have I got here? Oh, I think I've already shown you my 10 frames and my Hungarian 5 frames. And I go hunting for ice cube trays that have only got 10 sections in them, because actually that's a 3D 10 frame, and we can do lots of work kind of using that one as well. Just having lots of numbers around. So these are some numbers that actually one of my lovely teachers made these for me. These are the resin numbers. So she made me a whole set. And because she knows I love glitter, she put glitter in the numbers as well. So just kind of having those out and about, really, really nice. I mean, I've got things like my counters, I've got my pom-poms, got my subitizing plates. So I think, the idea is that you can have resources that you can make, resources that you can buy, but actually having them is really important. So there's kind of that list. And again, I could have added to it, but you have to stop somewhere. So let's just think about those 3 areas that I kind of just highlighted just to kind of talk to you about. So, we've got the sandpit, we've got the water area. So what maths is going on? And this is if we've set things up. So we are enabling these things. But if I've buried things, if I've got animals that are buried, or even the Numicon buried or the Cuisenaire, then, children are going to dig them out, fish them out, etc. And we're already enabling the children to do some counting and some cardinality if they want to. That comparison between, what's the same, what's different, how many have you got, this jug is this full, this jug is this full. Lots going on there. Getting some estimation there. How many do you think are buried? How, do you think I can pour this jug into there? What do we think? That volume and capacity, and also that measuring. So just kind of looking at those areas through a mathematical lens. Often you think, yeah, actually, if I just did this, this, and this, then I've really mathematized something that perhaps I didn't think was, that maths. Construction corner. So I always kind of want lots of different construction corners, because you want the really big construction corner, which is your block play, but you also want your small construction corner, which is kind of, your threading beads, or just putting those little beads into the kind of the I don't know what you call them, the trays with the holes in. There's a word, I can't remember what it is. But all of that construction area, I mean, children love it. Stacking up their kind of the bricks really tall, building things, particularly the block play, super, super, super important. And it's really kind of, it's accessing your spatial reasoning, which is access, it's, you could call it a STEM corner, because actually they're doing science, technology, engineering, and maths all at the same time. And then let's just think about the book corner. So again, here, there's a couple of things that we can do here. The first thing we can do is that we can make sure that we've got some maths fiction books. So I've put a few of my favourites along the screen. I did just grab a couple as well. So there's Anno's counting book. Love this one. Basically, it's a picture book, but the pictures are beautiful. You've probably seen it. But lots and lots of maths going on there. Doorbell rang. I love doing that one, and you can see how old this one is. The 10 dots, because I'm always doing an activity on those 10 dots with stickers and things. So just making sure that you've got some maths fiction books in your book corner is really good, but also just having some manipulatives as well. So I often just have like a wicker basket of Numicon, or some loose parts, or maybe a couple of, kind of bead strings, so that if the story does have some maths in it, then the children can be accessing it as well. But if not, they might just go and sit in the book corner and do some maths. They might not even go to the book corner to read a book. They might just go to do some thinking, do some kind of sleeping, do whatever. And of course, those links to Oracy are super important. So making sure that, any displays are, just looking at any displays. So I can see an under the sea. So, we've already got under, that's positional language, just kind of thinking, okay, the display's all about, a theme or a book, but have I got some mathematical words there as well? And then the other thing we can do is, and this again, one of my schools did this, is that in order to kind of, all of the books have got a number on them. So they've got a little sticker that says this is book 1, book 2, book 3. And then the children have to put the book back in the right section. So you can see here all the books are being put in the 1 to 20 section, or the 21 to 40 section. Now, we're not expecting children to know the kind of the understanding of these numbers, but what we are expecting is that they can look at and over time and put it back there. So, and even if they can't, it's just having numbers around them as well. So that's kind of maths in the environment. Okay, so let's start thinking about those 3 areas. So the first one I talked about was number sense, and again, at the moment, a lot of curriculums I see for early years are dominated by number sense, so maybe 80–90% of the curriculum is all about number. And I guess what I'm going to ask you to think about is number. Obviously, it's really, really important, but so is patterning and so is spatial reasoning. And together, those 3 do really make up the kind of the holistic part of our curriculum. I'm still going to do measuring, and I'm still going to do some statistics. So, they're up here as well, but that number sense, patterning, and spatial reasoning, really important. Okay, so what is number sense? Well, it's kind of 3 things. So it's counting and cardinality, comparison, and composition. So we'll just unpick those really quickly just to make sure we're all on the same length. How do we do it? We use a lot of manipulatives. It's about making sense of that problem, working together, and really importantly, kind of giving the children opportunities all the time to mark make, all the time to record their ideas and share their findings. So, lots of clipboards or lots of chalk or, lots of air writing. But that idea that we want them to record. So just kind of going into counting and cardinality. So this is about, do children know the number names? Can they recognize that pattern of counting forwards and backwards? Always count backwards and forwards, forwards and backwards. Just that's, really important. If we want children to be as strong at subtraction later on, then we need to do that counting backwards as well as forwards. Um, Crossing boundaries, we often stop at 10. Why? Why do we stop at 10? Why don't we just go on to 12? Because that crossing that boundary is actually really, really helpful for children. It doesn't mean that we have to look at the composition of number 11 and number 12, because this is in the counting and cardinality bit. But just being able to say, 7, 8, 9, 10, 11, 12 just crosses over. So that might be something that you want to consider. Having that idea that there's one number for one object, when we begin, that's really important, keeping track. And then, of course, we have the 5 counting principles. So I won't test you on those now. But these counting principles go, back to the 70s when Gelman and Gallistel kind of said, actually, children need these 5. So we've got the stable order. So, being able to say 1, 2, 3, 4, 5, not 1, 2, 4, 3. So that just having that stable order is really important. One-to-one correspondence, again, making sure that actually one object, that's 1, and then that's 2, and then that's 3. How do we keep track? We might put them in a line, we might touch count. That's the second principle. The third principle is your cardinality. So I might say to children, they might have some objects in their hand. I might say, how many have you got? And they might say, 1, 2, 3, 4. If I don't ask, so how many have you got all together? I don't know if they've got cardinality. So how many have you got? How many objects have you got? 1, 2, 3, 4. So how many have you got all together? 4. If they can say 4 because they've recognized that last number in the count also indicates the number of the total of the group, then they've got cardinality. Quite often I'll say, how many have you got? 1, 2, 3, 4. So how many have you got all together? 1, 2, 3, 4. How many have you got all together? 1, 2, 3, 4. So I go, so you've got 4. So kind of that modelling. So that's the third one. The fourth principle, it's the really, really hard one. It's where you have, so you might have like some pom-poms, and let's just say I've got 3 for now. And I might say, so how many pom-poms have we got? And the children might say 1, 2, 3. I need to say, how many have we got all together? But then I might say, can you make the yellow pom-pom the first one? Now, to begin with, what they do is they move it. But actually, over time, I don't want them to move it. I want them to be able to say 1, 2, 3. How many have you got all together? 3. Could you make the pink one the last number that you count, the last object that you count? 1, 2, 3. How many have you got all together? 3. So that it's called order irrelevance. And that order irrelevance principle is one that's often missed. And it's one that I think I see as I go through primary school when children have got wobbly foundations. They often it's to do with their counting principles or their lack of counting principles. And then the fifth one is what we call the abstract principle. And this is where children can count things that they can't see. So I might clap. So I might say, how many claps did you hear? Because they can't touch them, they can't move them, they've got to use different sensors. So again, we can do that one quite a lot when we're lining up, maybe getting that into one of those routines that we talked about. So that's counting and cardinality in a nutshell. And I think it's probably the hardest thing that we do, counting. I think people think it's the easiest, but I think it's actually the hardest because we have to do it so much over and over and over. And we have to do it for years and years and years. So I can't remember who said it. Somebody important, not me, said it takes children around about 7 years to actually master counting, which I think is, that kind of, I think that's why we've got this counting research within the counting collections going on, because people have recognised it's so important. But there are two other things wrapped up in number sense. So let's have a look at those. So the next one is composition. So this is essentially, this is your numbers within numbers. We might call it partitioning. I've kind of moved over the last couple of years to calling it composing, decomposing and regrouping. And I've done that because that's the language I tend to use in spatial reasoning when I'm composing and decomposing shapes. And I just think there's so many words out there. So if I can minimize the amount of words we use, then great. So that numbers within numbers. So you can see there's some pictures at the bottom of the screen. Let's look at the ones on the left to begin with. And I might say to you, well, what numbers can you see on that far left one? And you might say, I can see a 4 and a 3 because you're subitizing. Yep. Or somebody else might say, I can see a 3 and a 4. Or we might say, well, can you see a 2, a 2, a 1, a 1, a 1? Yeah. Can you see a 2, a 2 and a 3? Yep. So again, you can see what I'm doing. I'm really trying to break up all of those different parts that 7 is made up of. So composition is I was going to say it's different to number bonds. It actually has number bonds within it. So number bonds are your kind of part whole, but actually composition is your part whole. So again, the next image along, you might be able to say, if you're looking at that, can you see a 5 and a 4 or a 4 and a 5? Because I'm doing that commutativity as well. Can you see a 2, a 2, a 1, a 2 and a 2? Or can you see a 2, a 2, a 2, a 1, a 2? What about a 3 and a 1 and a 1 and a 2 and a 2? You see what I'm doing? So again, just having lots of these out and being able to have these with objects and being able to just pull them apart, put them back together again. So that decomposing and then regrouping, really important. And I can do the same with coins as well. So sometimes I might do this with objects, with loose parts, with gems, with pom-poms, but also doing it with money just brings in that measurement a little bit as well. And then, of course, what we then do is we might go on to unitizing. So we might say, well, actually, now the blue is worth 2. And I'm sort of jumping ahead a little bit now, I realise, but that's kind of where it goes in that progression. So if each pom-pom is worth 2, then I've unitised and I've said that's 2 and that's 4 and that's 6. So again, just so we kind of know where it is. And that idea that we just flexibly decompose and recompose, I just think that sounds lovely. So that's composition. And then the third one is that we look at within kind of that number sense is comparison. So what is comparison? Well, it's actually a couple of things. So it's about having that sense of how big a number is. So knowing that 6 is smaller than 8, but bigger than 2. And that language itself is really hard. So we would have to be doing this practically. But that idea that, if I've got 3 pom-poms and somebody else has got 5, who has got more? Who has got fewer? So again, we can compare, we can line them up, and I can be like, well, I've got, here's a 1, there's a 1, and doing all of that. But it's also kind of involves ordinality as well. So being able to put numbers in order is a really good skill. And again, this is where we can have fun with early years. So we can go beyond their level of understanding of the numbers, because we can just use big numbers and say, well, where would we put 1,000,000? Yeah, we could put it all the way down there. So just kind of having those numbers, being able to put them in order. And again, ordering numbers we've talked about, we might be able to do that in kind of lining up time. And then estimating, something I don't think I'm very good at estimating. I kind of forget, I get a little bit too excited about doing the maths. So, I think it's really important to be able to say that that's why the estimation station works in early years. So, over time, being able to see that a group of objects has about, whether it's 5 objects, 10 objects, 20 objects, but having that benchmark and giving children jars of things to estimate before they count is really, really good. And they love doing it as well. So that's kind of your number. Okay, so again, pattern, what is it? So I'm going to give you some definitions from the research. So it's basically something that we can predict. Something that we can predict that's kind of has a regular structure, and it could be numerical, and it could be spatial, and it could be logical. So kind of that's where we're at. And a pattern is kind of how it's organized by its structure. And this is some of the really amazing work from Jo Mulligan, who is in New Zealand. She is kind of deemed the pattern researcher of the world. And her colleague, Michelle Moore, and they have written a lot about pattern. So why is it important? Because as I said, I shared earlier, I thought I was doing quite well at pattern. No, turns out I wasn't. So why is it important? Well, you're not going to be surprised. It's also that kind of that wrapped up in that number being able to predict. Pattern can also predict later maths achievement. And what they've realised is because pattern is the foundation for algebra, and algebra is, essentially how well children do at secondary school, those children that are kind of exposed to pattern in the early years, they tend to start to recognise the structure of maths and kind of the representations and how to understand some of those more abstract concepts. They just seem to get it easier than those children that haven't been exposed to pattern. We also know that high achievers are very good at visualizing, so kind of, imagining what's in their head and manipulating that information. And so we know that if high achievers are good at doing that, then we can kind of use that for everybody. That's why that's there as well. So again, kind of different bits of research, and the research isn't that new. This has been out quite a long time. So that's just a list. I'll just give you a minute to read that of what pattern encourages children to be able to do. So there's quite a lot there. And I think if I kind of showed that list to any adult, any teacher, any practitioner, any parent, they'd say, oh, I want my children to be able to do those things. Because actually, these are the things that children are going to have to do in the future, aren't they? In the world of AI, all children are going to have to be able to reason and problem solve. They're going to have to be able to visualize in their head and kind of be, have that kind of that logic and communicate and collaborate and have that numerical and spatial awareness and think algebraically. So if we can do that in early years, I guess, why don't we? That's kind of the thing. Okay, so what types of patterns are there? So let's classify some patterns. So we have patterns that repeat, so, over and over and over and over. And then we have patterns that grow and because they grow, they also shrink. So those are really the two kind of main types of patterns. We have within repeating patterns, we have linear patterns, so patterns that go along in a line. And then we have patterns that go around a border that are still repeating, but they're going round. And then we have spatial patterns. So we've already looked at a spatial pattern when we looked at the Pritt sticks organised in this spatial arrangement of 5. That's a spatial pattern that's linked to a number, but again, a really nice spatial pattern. And so we have patterns in maths, in all areas of maths and across, in everything. And so I've tried to include a few pictures for you as well here. So does anybody want to just kind of suggest what do we think? What do we think's going on with the pattern on the left-hand side? Does anybody want to just either put something in the chat or just unmute and tell? What do you think the children were doing? I'm going to give you a clue. It was a song. So they were singing a song and then they drew what they were doing, but it was a pattern. Any ideas what the song was? Anybody want to have a go? Pop something in the chat. What do we think? Any ideas? It's not monkeys in a tree. So that's my clue or not clue. Anybody got any ideas what this song was? Well, it was heads, shoulders, knees and toes. Knees and toes. So you can see the children, you can see the hands, you can see, yes, they are knees, you can see the toes. Those children had really just kind of taken that on board, and that's a repeating pattern. And then, giving them that opportunity to record, what they were doing was lovely. We've got the compare bears as our next photo, and we can see here now. Interestingly, you might notice that the bears are not the same size, so that's really important. It means that actually this child who was doing this is quite a confident patterner, because when we start, children have to. They're obsessed about having the same size and whatever. So this child is quite well along the patterning trajectory. So to begin with, we would always get the children to say what they see in words. So it might be red bear, yellow bear, red bear, yellow bear, red bear, yellow bear. And then over time, they might drop the noun. So they might just say red, yellow, red, yellow, red, yellow. Of course, if they're looking at it from the opposite way, kind of, 180 degrees, they might say yellow, red, yellow, red, yellow, red. But you can hear the repeat of the pattern. So there are a couple of really essential things that we need to do with patterning. The first thing we need to do is we need to be able to explain the pattern and identify the unit of repeat. And I am going to use, and I do use that language with all children. However young they are, I say to them, what's the unit of repeat? What's the thing that repeats over and over? So I always start with linear repeating patterns. So for example, children will start by saying, it goes red, yellow, red, yellow, red, yellow, exactly how you've just heard me say. And that's absolutely fine. And they might say that for weeks and weeks and weeks. But over time, I'm going to keep saying to them, so what's the unit of repeat? And then I want them to identify that the unit of repeat is red, yellow. So that's the thing that I can take and lift and put down, take and lift and put down. So then they start to say it's a red, yellow pattern. So that's kind of moving along. And then, and they do, this is kind of, adults modeling this, but then they will be able to symbolize it, because they'll say it's an AB pattern. And what they mean is it's got two elements within the pattern, so AB pattern. And then that abstracting, they might be able to say, so somebody might have made a red-yellow pattern, but somebody over here might have made a blue-green pattern. So different colours, but they're both AB patterns. And that abstracting, being able to say, I've got an AB pattern and you've got an AB pattern, is abstraction, and that is the beginning of algebra. So that's kind of where we're going with that. So that repeating pattern is really interesting. So you can see the picture at the top. This is now going round a border, and this is lovely. These are yogurt tops, by the way, and the teacher's just left out loads of yogurt tops, loads of these shapes. and the children are just sitting on the carpet and they're just trying to make the pattern fit. And so when I'm watching them, I'll often say to them, do you think it'll work? I mean, and children will often go, yeah. Like, oh, okay. Love the confidence. Um, and they will make it work because they invent their own rules. So you can see with that one that there are quite a few gaps. So over time I might say, well, what do we think about those gaps? Do you think can we fill in those gaps anymore? Looking at that pattern at the top, does anybody want to suggest kind of what the pattern is? It's not an AB pattern, is it? So does anybody want to maybe think what pattern is it? Any ideas? Oh, hang on, move back. I've lost my chat somewhere. So we're going to say it first. It depends where you start from, but I might say, you can see I can put my head on my side. Red, purple, purple, 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 red, purple, purple. Oh, so first of all, it works. Brilliant. I don't know whether anybody's put anything in the chat, but if you have, you might have put ABB. And what I find is that actually very young children kind of get this quite quickly. I mean, over the course of a year. And then down below, you can see that this child has been annotating, they've been mark making. And really interestingly, most children use capital letters for recording the pattern, even though we're doing lowercase with them. It's just one of those things you're like, oh, so they don't actually seem to have a problem. And this child has just got some coloured pencils. What's she doing? She's doing an AAB. Oh, AAB, AAB. Yeah, AAB. So she's got 2 units of repeat. I think another one is ABC, ABC. So again, really lovely patterning going on. So I'll just show you some photos of children patterning. So let's kind of go top left. So this is one of my schools in North Norfolk. We have a lot of potatoes. So the teacher had put out loads of potatoes, and I think really in a way of kind of, just being able to fire them down the drain pipe. But actually this little boy was just obsessed with making a pattern with his potatoes. So again, really important to say, oh, so that looks like, what's your pattern? And, they always look up as if you're, slightly mad and you can't work it out, don't they? And he said, big, big, small, big, big, small, big, big, small, big, big, small, and carried on. And then the teacher said, oh, right, lovely. So what's your unit of repeat? And he said, AAB, as you do. And then, of course, the next question is, how many units of repeat have you got? So even though he's patterning, you can hear the counting and the cardinality coming out as well. If we go down, we can see that Kitty has been doing some patterning work. So she's got some shapes, some 2D shapes. And actually she's just broken what I've just said, and she is using lowercase. So she's got hexagon, circle, hexagon, circle, hexagon. So I always have to say it. And what I've noticed here is that the hexagons are different colours and the circles are different colours and different sizes. So she's really confident. She's told me, she's said, oh, this is a B, A, B, A. So I said, and actually it wasn't me, but the teacher was there, and the teacher said, so Kitty, how many units of repeat have you got? And Kitty looked at the teacher, and Kitty's in reception, and she said 2.5, which we all fell over. Just went, oh my goodness. And so the teacher hadn't done fractions. So there we go. Carrying on down to the kind of the cable reels. Again, this is Sue Gifford's, do it huge, do it outdoors. So the teacher had found some cable reels. And actually what we have here is a growing pattern. So depending on where you're looking, it might go 1, 2, 3, 4, 5, or if you're looking at where this little girl is, it might go 5, 4, 3, 2, 1. But yeah, really, really lovely. Up at the top, this little boy, He is actually doing his pattern assessment. So I did some pattern assessments with the schools that I work with in the project, and he is making a train. He's been told to make a train of repeating, red, yellow, red, yellow. So he's made his train and he's just doing some recording. Below, we've got a whiteboard, and these are two separate patterns, by the way. So we've got triangle, triangle, circle, triangle, triangle, circle, triangle, triangle, circle. So again, I've got an AAB pattern, and then underneath, I think that's circle, oblong, triangle, circle, oblong, triangle. Yeah, and circle, oblong. And I don't know if that's a squished triangle or we've just run out of room, but it doesn't seem to affect the children. On the top right, far right, we've got these pattern strips. This is something that the teachers invented. So they did a pattern strip and then they divided it up so the children could kind of get their units of repeating. So I don't know whether you can see, but he's been sticking pasta onto his pattern strip, and it goes wiggly straight, wiggly straight, wiggly straight, wiggly straight. So he's kind of, he's got his unit of repeat within each segment. And the growing pattern of the bricks, foam bricks in the classroom, can I make a growing pattern that's as tall or taller than me? So some lovely things going on there. Okay, so this is my last slide on patterning, and I'm just going to let you read this because this is something that one of our teachers observed. And I think you agree that is pretty amazing. Okay, so I don't know how much you have been exposed to spatial reasoning, but essentially, what is it? Well, it's kind of everything that we do. So it's that kind of relationship sort of within and between spatial structures and how we communicate about them. But that doesn't really help me a lot. So we've kind of all been taught to think about the world, but can we think about it spatially? So here are three examples, and this is from Emily Farron's work. So the picture at kind of on the left, loading a dishwasher. Don't know if it's the bane of contention in your house. It is in mine. But when we load a dishwasher, we don't just throw things in haphazardly. We think, oh, well, if I just put that cup over there, then I'll be able to get more cups in, or I won't put the plates there because the plates would go better there. That is, we are using our spatial reasoning to load the dishwasher to get the most kind of, use of the space. That's essentially what it is. The middle picture it's a pair of trainers in a box. And when you buy shoes and they you open the box and they're kind of in that kind of, way so that they fit. Now, I've been doing spatial reasoning now for about 4 years. So I know this. And every time I open that shoe box, I think, I'm going to get this right now. I'm going to get them out, the shoes out, and then I am going to put them back in one go. Nope, still can't do it. Even though I'm kind of going, no, I know they need to get that, and then they need to turn and flip. No, no. So again, it's kind of like, I'm aware, but I obviously struggle with that bit. And map reading. We probably don't use a lot of real kind of maps at the moment, but we definitely, by using maps, by using our Google Maps or whatever we're using, that kind of navigation, kind of, really thinking about that spatial reasoning. So driving a car, hopefully we stick to the lane, we can kind of park. Every single thing we're doing is spatial reasoning. So what does the research say about it? Well, you can probably guess. You can probably guess what the research says. So, it actually there's a lot of countries now that when I go to countries and I talk about spatial reasoning, they look at me as if to say, "What do you mean you're not doing it? Like what? Like you're What do you mean? We've been doing this for 10 years. So this is from that research that it's actually so well established. It no longer makes sense to even kind of question why we're not doing it. And as I kind of mentioned earlier, we don't have an early years curriculum in England, but we do have an early years statutory paragraph for each of the subjects. And in the maths paragraph, it talks about the importance of number, the importance of patterning, and the importance of spatial reasoning. So it is there. So it's just trying to get that out a little bit. So here we go. If you've got strong spatial skills, you tend to perform well in maths. I mean, you knew this was coming because actually that big picture of people who are, confident at maths will do better. And it is there. But because it's kind of a fairly new thing over the last 10, 20 years, there's a lot of research, and there's a lot of research that keeps coming out about it as well. So what they're saying is the research is saying that actually if you're good at spatial thinking, spatial awareness, spatial reasoning, doesn't matter which phrase you use, then actually you are going to be better at arithmetic, word problems, measurement, geometry, algebra, and calculus. And I will try and just give you an example to show you kind of how it relates. But kind of that's good enough for me. And if you've got good spatial skills, you can predict the children that are going to be better at maths. Yes, by the time they're 11, but actually the spatial reasoning research goes all the way up to GCSE and beyond. And that's the Mix and Cheng research. So here are some examples. What does spatial reasoning look like? Lots of different things. So we've talked about map making, but equally going out on a walk. You will know that very young children, when they kind of, when they're running out and about or when they're in the classroom, they just bump into things. You're like, what? How have you just walked into the table? It's because their spatial awareness hasn't yet developed. So they will have to kind of really think about, their brain is having to kind of navigate round that furniture. That's why obstacle courses are so, so good for children to kind of, get their spatial awareness going. That's another reason why I encourage practitioners to change their classroom orientation regularly so that it kind of is really helping with that spatial reasoning. Other things that we do a lot of in earlier settings, things like the jigsaws, and you will see a child and you'll see them trying to kind of fit that jigsaw piece, and you're kind of like, no, you just need to turn it, just flip it, just rotate it. All of those words are spatial reasoning words. So things like fitting in the puzzles, can you fit the triangle into the square block? Very young children will try because they haven't yet learned that doesn't go. And their determination and their perseverance is, it will go, it will go. Of course, it doesn't. Isometric paper, that's the dotty paper. I often just have, I often have a cutting tray or a paper tray in the classroom, and I just have different types of paper, and having that dotty paper is really nice. And then there's just a couple of other things. Those that were probably, none of you are old enough to remember Tetris, but I remember playing Tetris and that kind of, the shape coming down and having to kind of figure out where it was going to go. There are lots of other games like Minecraft now that are doing the same thing. And that's that kind of thing in the middle where you've got a shape, you've got your two, I think they're cuboids. But if you're looking at it from above, what are you looking at? And, that's kind of, that's your year 6 example, but that's where spatial reasoning kind of fits in. So what does it involve? There we go. There's your list. So on the left-hand side, this is this kind of what we would call the spatial relations list. And on the right-hand side, that's what we would call the shape and space. And this actually comes from the ECMG Spatial Reasoning Toolkit. So if you want to just lift something and use the Spatial Reasoning Toolkit, do feel free. And I can give you those references. But ECMG is the Early Childhood Mathematics Group. That is just a group of volunteers. So we don't get any funding. We don't, we're not beholden to anybody, and we have a lot of resources on there, and this comes from there. So we've done a lot of research, and we've actually written a spatial reasoning toolkit. So all of these things are, and the spatial reasoning toolkit is from birth to 7. So it has the trajectory from birth to 7-year-old. And all of these things are in there. So you will recognise, you might have been thinking, I don't know what spatial reasoning is. Looking at that list, you'll be like, oh, yes, well, position, distance, direction. Yeah, these are things that we're doing. Orientation, can you take the register back to the office, but can you go via year 4 or something? That movement and rotation, being able to move and rotate. Perspective taking was a new one to me. But that idea, we do quite a lot of it in Small World actually. But kind of setting up activities where we definitely do perspective taking is really important. Scaling, so being able to kind of say, well, actually, Jack and the Beanstalk is perfect, isn't it, for scaling, those kind of things, and that navigation. So that's your space part. And then your shape part, again, things that we would recognize, but being able to identify what shape is, it's wiggly, it's curvy, it looks a bit like a cloud. Then looking at the properties of shape. So, oh, that's got straight sides, that's got curvy sides. Then being able to take a shape like a square and being able to cut it into 2 triangles to say, well, actually, so, I've decomposed it and now I'm putting it back together. So composing and decomposing, really nice, so that children can see shapes within shapes. So just as I was talking about numbers within numbers for composing, shapes within shapes is really important. We've got that structure coming through as well. So that structure of shapes, how are shapes made up? How are they built? What happens if I put things on top? And we've got scaling there as well. So in a nutshell, that is spatial reasoning. Any questions? Because what I want to do now, just kind of going into the last part of the webinar, is really pick up on play-based learning and the importance of play, which of course we all know, but it's always nice to be reminded. But those are your 3 kind of what I would call your 3 big areas for your early years curriculum. Kind of what can we do? How can we get it into the environment? How can we do maths every day? And what maths can we be doing? That number, pattern, spatial reasoning, with a bit of measurement and a bit of data handling as well. Okay, so let's move on to thinking about play-based learning. And I've gone right back to Vygotsky, so I will just give you a minute just to read that quote from the Vygotsky research.
Alison, you've got a question in the chat.
Oh, brilliant. Let me see if I can access it. Oh yeah, there we go. Oh, I remember Tetris. Yay, somebody else. How can we make it easier for 3 and 4-year-olds? Which bits don't they understand? I mean, I think a lot of it is about exposure, about modeling, just kind of giving them lots and lots of opportunities. Is there something more specific you're thinking about there? I mean, everything that I'm talking to you about, I mean, I have nurseries from 2-year-olds that I go in and support, but certainly, I think we kind of expect 3 and 4-year-olds. They don't necessarily have to understand yet. It's definitely that exposure. But if there's something a little bit more specific, do pop it in the chat and we can try and unpick that a bit more. I can see that you're typing. Yeah, that exposure, I think it's it's really, really important that when and I'm about to kind of just talk about that play-based learning. If children are playing with the Numicon or they're playing with the patterning, they are actually, it's their highest level of learning. We know that. So, don't be afraid to kind of let them play, let them just, have lots of things out. It's, even kind of going to those bigger numbers, I would not expect bigger numbers, children to understand bigger numbers beyond 10, but it doesn't mean I'm not going to go beyond. It's that exposure again. Yeah, I mean, we all know that, if children have had some counting exposure and, they've played with jigsaws before they come to nursery, then they are a little bit more confident. But actually, what I tend to see is that, within those, however long you have them for, whether it's 2 or 3 years or even a year, we can actually catch up all of the children if we do the right sort of stuff, if we have that right balance of number patterns, spatial reasoning, the right balance of pedagogy in terms of direct teach and play-based learning and child-led. Actually, children just can fly. So I think for the adults, it's exhausting because we're spinning a lot of plates and we're constantly setting up the environment in lots and lots of different ways. Um, but yes, I think it is about just keep going, and I'm kind of looking at the progression over a period of time rather than day to day, which I'm sure you're doing anyway. Keep asking the questions. I'll try and keep an eye on the chat box. It keeps wanting to disappear, but I'll try not to let it. Okay, so why play-based learning? So I mean, you know this, I know you do, but it's just nice to have a list and maybe somebody else to kind of tell you the things that you already know. So, I mentioned earlier that I work for Lego Education, and their whole philosophy is about children playing and adults playing. And when I certify people to be a Lego Education trainer or not, often if they don't pass the certification to begin with, it's because they're not playful enough. So, Lego have done so much research, they've worked with Harvard University, they really get it. And so I try to kind of, sort of say to people, particularly kind of head teachers or CEOs, actually, if children are being playful, and I try to use the word playful rather than playing, because I don't know, it just seems to have more gravitas, then they are learning at the highest level they can. They're making decisions, they are motivating, they're developing their agency, they're communicating, they're collaborating, they're risk taking. This is what play-based learning does. So it does develop those knowledge and those skills, but it's really accessing that higher level of thinking. When they're sitting on the carpet with me with the direct teach, they're not accessing that higher level of thinking. I know that. But what I'm doing is giving them the skills so that when they go to play, then they can start to use the knowledge that I've given them to then access that higher level of thinking. But that's also why I'm really kind of like, I don't want to keep them on the carpet too long because I know that I've limited their thinking. I'm doing the thinking for them. And there is a time and a place for that, but I want them to then, go and do things. As long as I've got the environment right. And sometimes I look and I think, no, that isn't in that right place. Nobody is there. Nobody is playing, or I need to kind of change it. Um, so again, kind of the way that we set up early years is just such a privilege, isn't it? That it does have that holistic environment. So it does help children to develop in all areas. And as I've mentioned, become more comfortable, confident, risk taking, problem solving, bringing out their own self expression and creativity. So, some really good things there. And of course, there are different types of play. So, just being able to recognize and enable in the environment the different types of play. So it could be that children are playing with objects or materials, that's fine. And it could be that they're just playing with something like, the Numicon. Physical play, so actually being outside or inside, but running around, having an obstacle course, throwing bean bags, kicking balls, all of that kind of physical play is important. Pretend play, so again, having that kind of that role play, using a banana as a phone, that type of thing. And how do they do that? Well, we're going to model it. We're going to model all of that. So I might be doing my direct teach. I'll be like, oh, sorry. I think somebody calling. Yeah, and I'll pick up my banana and go, yeah. And I'm sorry, I'm just in the middle of doing some teaching. Yeah, yep. Oh, right. The teddy bear needs what? Right, the teddy bear needs a picnic setting up for this afternoon. Right, okay. Well, I'm really sorry, everybody, but we were going to do this thing, but I think, Pat, we've just got a memo from the teddy bears that they would like a picnic this afternoon. can you help? You know, it's that type of thing, isn't it? Kind of that symbolic play, again, kind of that conveying that meaning, again, bringing in that, you know, that importance of oracy. And then, you know, having games that we might teach the children a game, but really we want them to invent a game as well, don't we? So how do we facilitate play-based learning? Well, hopefully we've kind of, you know, we've kind of got, you know, lots of ideas, but we do need to give children that space and that time and that decision making, that agency, that autonomy that they can kind of develop. We kind of, you know, really want to think about what activities are going to kind of get their interest, what's meaningful. We talk about this a lot, don't we? What's, you know, setting up, you know, the dog role play wasn't meaningful to them. I thought it was because they were talking about dogs. But actually, I did it. I kind of said, oh, I'm going to have it nice here and I'm going to have the carpet here. And it just was, I thought it was lovely, but they chose not to. So that environment, just having a look at your environment and just, and I often have to kind of then go down onto my knees when I'm in an early years setting, and I just think, this is what children are seeing. So if there's some really lovely stuff up here, they might see it, but they're not necessarily going to use it. So, you know, do I want to go over there or do I want to go there? Just kind of really thinking about that, really making sure that we've got that language rich resources. So whether that's kind of having lots of books everywhere, you know, making sure that we've got the mark making, but also those keywords coming in as well and modeling that kind of that key vocabulary. And then just thinking about the physical layout, you know, making it as, dare I say, complicated as possible for adults to get round, because we know that we're developing that spatial awareness and that spatial reasoning for the children. Okay, so what I'm going to do, and this is kind of probably going to be my last slide, and then hopefully we can just take any more comments or questions. I've got a video that I'd just love to show you. It's on YouTube. You might have seen it. It's called The Builder's Yard. It's about 5 minutes long, but it is kind of one of my favourite videos. These are reception children, so a little bit older than nursery, but there's two things going on. So first of all, it brings out the holistic nature of early years, which I just think is lovely. You know, it's not maths, it's not English, it's not science, it's not small world, it's not social emotion, it's everything. It's just everything. But I want you to kind of think about, what have the adults done to enable what's going on? So that's the kind of the big thing, you know, how has this kind of, you know, how has this come to happen? And then the other thing is the narrator is brilliant, because as we know, sometimes people can come in and they can stand in an early years classroom or setting and they can say, well, what are the children doing? And you look and you think, well, they're doing this, they're doing that, they're doing the other. And actually this narrator brings it all to the forefront. And I just think it's brilliant. Um, so Kelsey and I have tried it. We did try it at the beginning and it did play with sound. So I'm going to keep everything crossed. And as I say, this is kind of my last slide so that we can watch the video, we can have a chat about the video or chat about any other questions that you have. So, can you see the video
Builder Samaya
and hear it?
Cash and
Yes,
still in
yeah,
brilliant.
all good.
Yes. A brush for her next project, bricklaying. He sorts and hands over the money requested. A bit more than 8p. Accepts her change contentedly, carefully loads her purchases into a basket and sets off to the building site. Samaya carefully loads the trowel, places the mix on the brick, and with fingertip delicacy levels the sand. She fetches another brick, puts it down, and then turns it over so that the correct surface to fill with mortar is uppermost. Just enough mortar is used to fill the frog, the indentation, before she levels it off. Meanwhile, across the site, another construction is in progress. Success requires careful balancing. The builder's companion is fascinated by the pattern left by the bricks when they are lifted away. The tower is embellished with straw all around it, and a brick border constructed to keep the straw contained. Protective clothing is seen to be important. One builder helps the other to put on ear protectors. He places them carefully, and the boys move in synchrony as the hat is retrieved and replaced. Back to work. Samaya's laid all her bricks, so it's back to the builder's merchant with a less than warm welcome for their loyal customer.
It's not your turn.
Another customer, pushing in with his sticks, is firmly rebuked. The second assistant's equally brusque.
Sorry.
The tower design is being adapted. The straw has been abandoned in favour of the newly purchased sticks, but the containing structure of the bricks remains intact. The boys work together, filling the space. With the stick supply gone, they negotiate the turn-taking needed to replenish their stock. One fetches the barrow, whilst the other sorts the sticks.
Are they nearly finished, all the sticks?
Noticing stick supplies are nearly exhausted, they anticipate a future need.
Yeah. Then we have to get from straw to make it strong.
Finnegan rushes to help James as the barrow hits the water tray.
And we don't need to.
With one at the front and one at the rear, the obstacle is easily overcome. Samaya's mortar mix is getting dry. Luckily, a water supply is to hand. Accurately placing the bucket under the tap, she gets what she needs. Lifting the water container with two hands, she pours the contents into the sand, tipping with one hand and steadying with the other to make use of every drop. The brush is now the favourite tool for applying the watery mix. The tower constructors have nearly filled the bottom layer with sticks, so the next design idea emerges.
Amy, you have to put some in the holes. Not bendy one.
And is refined. No bendy sticks. This is delicate work. Sometimes a stick is just too thick to fit, and sometimes the structure needs a steadying hand to ensure it doesn't topple. Meanwhile, prepared bricks are placed with two hands on Samaya's growing structure.
Okay. Oh, let me just stop that one. Okay. So, I mean, just an amazing video. I just love watching it. But, you know, as I was saying, there's a couple of things going on there. You know, I think, I don't know, but I think the school has had a building project. So I'm kind of guessing that the builders have been in and they've kind of, you know, donated a few bits and they've shown children how to build a wall, etc. But then that entire playground, where kind of that setting is, has been taken over. And, there's just so much going on there. But for me, it's the narration as well. It's that kind of just being able to bring to life that play-based learning is super, super important. So, okay, so I'm just going to hop back into the hang on, there we go. I think I'm literally at the end. I don't know if it's any questions anybody would like to ask me. So the resources, it's the Early Childhood Maths Group. If you Google ECMG Maths, it will get you to the ECMG website, which is huge. It's kind of building all the time. So the Lego course. So this is so you have to be attached to a Lego reseller, and I'm trying to remember the one that's near Wales, but you could just Google it. And if it was something that you thought, oh, I'd quite like to become a Lego education trainer, then you would contact your reseller, because what happens is that these education kits are only available through the resellers. You can't go and buy them in Toys R Us or toy shops or whatever. These are just the education kits. And so Lego have it's kind of like it's an amazing kind of philosophy. They won't let anybody sell the Lego kits who haven't got people who can train and help schools. So it's kind of like a flawed business model, but a really good moralistic kind of approach. So if you kind of, and they don't have to be near you, the resellers, but if you found a reseller that's near you and just kind of had a look, approached them, then yes, then you could become a Lego education trainer. Yes, I know the AB patterns. It's yeah, it is really bizarre. Until I did the research, I was kind of like, surely children can't use the unit of repeat, and they can't do these things. And actually, they just do. But if you look on the ECMG website, so we've got number, pattern, and spatial reasoning. So we've got a spatial reasoning toolkit. We're just in the process of about to publish a block play trajectory, but we've also got number, pattern, and spatial reasoning assessments, kind of like low level and really, really nice assessments. And with those assessments are lots of videos. So you will be able to see kind of real children. The videos are wobbly because it's just the teachers on their phones videoing the children. But you'll see them actually, very young children going, is that an AB pattern? And you're like what? This is amazing. Yeah. So, yes, dishwasher. I mean, it either seems to be fair, my family don't even be able to open the dishwasher to put them in. They just seem to think that if you put it on the top, it somehow just magically goes from the work surface into the dishwasher. But there we go. Yeah, really pleased you've enjoyed the session. Yeah, it's been an absolute pleasure to talk to you all. I wish we could have done it in person, but there we go. Always better in person, but hopefully it's been okay online.
I just want to say a massive thank you. We've gained so much. You've shared so many things to consider, and I'm going to definitely try out that AB pattern with my little girl because she's doing patterning at the moment, and that's something that I've never considered. So yeah, loads and loads. Just thank you so much just for your wealth of knowledge and experience and just sharing that with us this morning. Just thank you so much.